So, as I said earlier, my name is Rashid Oguniro, and I'll be moderating this session. And our speaker today will be taking us through another session under data engineering experience. We all know that we have a new baby now on Microsoft Fabric. It's a platform, it's an end-to-end platform created by Microsoft for data analytics. And so it's something that has come to stay. And we as early adopters, we need to, take it very seriously. And so that is why we as a community, Nigeria Data Platform has come up with a 13-week series, to help our viewers to key into this vision. So today we've dealt with Power BI. Now we are in data engineering, and so today we'll be looking on the use of Apache Spark. So, ladies and gentlemen, let us welcome Anne Efeturi to take us through how to use Apache Spark on Microsoft Fabric platform. Thank you.
Thank you. Thank you, Mr. Rashid. Excuse me. Okay, so give me a minute. I'm going to share my screen. Okay, so again, good afternoon, good morning, good day, good evening from wherever you are watching us from. Today we are going to do a walkthrough on use Apache Spark in Microsoft Fabric. Please confirm if you can hear me. I
I
don't know
can
if
hear
I
you
have
loud and
my
clear. You can
camera
go
on.
on.
Let me turn on
Go.
my camera.
You can. I
Okay.
can hear you loud and clear.
All right, okay, that's fine. Thank you. All right, so I said we'll be looking at use Apache Spark in Microsoft Fabric. My name is Anna Efeturi. I will be facilitating today's session. Like I said, we want a walkthrough. It's a walkthrough. So we invite you to participate in a practical session where we'll explore the exercises on Apache Spark in Microsoft Fabric as featured on our Microsoft Learn. So our learning objective today, we want to look at configure Spark in a Microsoft Fabric workspace. We want to also identify suitable scenarios for Spark notebooks and Spark jobs. We want to use Spark data frames to analyze and transform data, as well as use Spark SQL to query data in tables and views. And lastly, we are going to visualize data in a Spark notebook. What is Apache Spark? Apache Spark is a unified open source engine designed for large-scale data analytics, which allows you to distribute computation tasks across a cluster of computers. It also supports various tasks such as data processing, machine learning, graph processing, and streaming. Some of the key features include multi-language support. Apache Spark supports multi-languages including Python, SQL, Scala, Java, and R. Another feature is batch streaming data. It can process data in batches and real-time streaming. SQL analytics. Apache Spark can execute fast distributed ANSI SQL queries for dashboarding and ad hoc reporting. Data science at scale. It allows you to perform exploratory data analysis on petabyte scale data without having to resort to downsampling. Machine learning. You can train machine learning algorithms on a laptop and use the same code to scale to fault tolerant clusters of thousands of machines. Each workspace is assigned a Spark cluster. You have workspace admins that can manage settings for the Spark cluster in the workspace setting. We have some configuration which includes node family. The node family is the type of virtual machines used for the Spark cluster nodes. In most cases, memory optimized nodes provide optimal performance. The runtime version Sparks to be run on the cluster. So you define the kind of version and you see it where it's going to be run on the cluster. Spark properties. Spark property settings can be done, can be enabled, or you can override in the cluster. Libraries. So the Spark library it is an open source ecosystem which includes a wide selection of code libraries. To establish an extra default library in the settings, you need an administrative permission. Just like we said earlier that we have a workspace admin, so you need like an administrative uh, permission to do that. And this is the workspace setting, and this is the Spark compute. You can see the node family, the runtime version, and then the high concurrency. So this is where you actually set it, but it is not for individual. The admin in charge of a particular organization does that for everyone within the organization. Run Spark code. To edit and run Spark code in Microsoft Fabric, you can use Notebook or you can define a Spark job. Notebooks consist of one or more cells, each of which can contain a markdown formatted content which we use normally for our documentation, or an executable code which we use to run our code. So you can run the code interactively in the notebook and see the results almost immediately, depending on the size of your data. Otherwise, you can define a Spark job to run a script or on demand or based on a schedule. Loading data into Spark data frame. The main data structure you work with in Spark is called a data frame. A data frame is a two-dimensional data structure that is similar to a table in a SQL database or a spreadsheet in an Excel sheet. So it's like a table where data is organized in rows and columns. So some key features of the data frame includes that its size is mutable, meaning that its size can be modified, to your desired size that you want it to be. It can potentially contain heterogeneous data, that is, different types of data can be contained within this data frame. The data is aligned in a tabular fashion in rows and columns. And then each column in a data frame typically contains data of the same type. E.g., you have a column for integers, you see that it's integers, for strings and for text, etc. Each row represents a record or an entry. It also has label axes like rows and columns, which means that the data can be located not just by the integer location, but by labels as well. So they can be created in various data from various data sources, such as lists, dictionaries, CSV files, and more. We are going to look at CSV file in the course of our walkthrough in the Microsoft Learn when we get to the demo session. On the screen, you can see a CSV file that has been transformed with a Spark code, and it's transformed. This is a typical data frame. You can see it has the header, the column header, and then it's made up of rows. So the code we were looking at the other time in the previous slide is actually called inferring schema. Now, in a situation where your data file doesn't have a defined header, we use an explicit schema, just as you can see on the screen, to define the header for each of the columns. So it means that the data file has no column names. So you are the one, after examining the data, you now define the data by using this code, instructing the product header, the product name, category, as the case may be, depending on your data. So that's the difference between the inferring schema and explicit schema. Transforming data in data frame involves applying a function to the data frame that modifies its content in some way. So you can use the select to create a new data frame from individual columns. So like the data frame we looked at the other time, permit me to go back 2 steps. Okay, so looking at this data frame, we can see product ID, product name, product category, and list price. So looking at this, we are selecting out of the whole names of columns that we have mentioned. We are selecting just the product ID and the list price. So, and that is what we are going to see. So it's going to come out in just those 2 columns. And we can as well use a where to filter rows. In this place now, we are trying to filter the rows with a where clause, and we want to see the product name, the category, the list price, but the category is just the mountain bikes. So by the time it's going to print out the results, we are going to see the product name and the list price for only this mountain bikes category. We can as well use a group by and aggregation function. This group by and aggregation function help us to select a particular group that we want, and we want it to be aggregated. Like what we can see on this code, what we are saying is that it's going to give us the product ID, and then the category is going to be grouped by the count. So we are going to see the count of each product ID. So that is how we can, and there are many more other transformation functions that we can use, but this is just a few among the lots that we can do with transformation. We can transform our data to how we want it, whatever the organization needs from us to transform and what they want to see. Using Spark SQL. The data frame API is part of a Spark library named Spark SQL, which enables data analysts to use SQL expression to query and manipulate their data. And finally, we are going to look at visualizing data. We can either visualize them in built-in notebook charts or with a graphic package code. So to visualize data, we need some libraries from the pandas, such as matplotlib and seaborn are required. So we are going to make use of that during the course of our hands-on session or our walkthrough exercise. So thank you very much for listening. At this point, is there any question? Please confirm if you can hear me. Am I still audible?
Question before we go to hands on.
Yes, you are.
Okay, Bazi, go on.
Okay. Give me a second. I'll share my screen. Sorry, just a moment. Okay, I think I just have to go ahead and okay, I think I'm set now. So let me share my screen. I'm going to share that screen. Okay, so please confirm if you can see my screen. I won't be able to
Yes,
see your
I can
hands
see.
up, so just use the
I
voice.
can see.
Okay. Okay, thank you so much. Okay, so here I have the Microsoft Learn exercise by my side so that we can go do a walkthrough of the exercise together. While I'm going to log in into my Microsoft Fabric, powerbi.com, and sorry, so I'll launch my Microsoft Fabric. I hope my system is not frozen. Sorry, I think something is wrong there. All right, so it should be app.powerbi.com. Okay, so here we are. We are in Microsoft Fabric. So we at the bottom left of Microsoft Fabric, we see the Power BI icon. So we click on it to bring out the session. So we are actually on data engineering section. So we click on data engineering. And then we have a whole lot that we can do. And what we need to do is that we want to create a new lakehouse, so where we are going to store our data. So let's
This year
create.
doesn't work on Saturday.
Sorry. Hello. 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 Can I go on? Is there any question? Sorry. Can anyone hear me? I don't know if anyone can hear me.
I can hear you.
Oh, okay. Thank you. All right. So let's create a lake. First of all, before creating a lakehouse, we need to create a workspace. Sorry. So let's create a new workspace. So the lakehouse will actually be in our workspace. So uh, what are we doing? I think, what should we call our lakehouse? Can anyone suggest? Our workspace. Suggestion, please.
Apache demo.
Apache demo. Okay. Apache. All right. So let's just keep it simple. You can give it description, a domain name, a logo if you have one for your company. Okay, so now our workspace is empty. So the next thing we need to do is to create a lakehouse where we are going to store our file. So we select a new lakehouse and we also name it demo. All right. Don't mind our name is long, but we just use it like that. We'll allow it to load. Okay, so now we have our lakehouse and we have our table section and our file section, but both sections are empty. It's now successful. So both sections are empty. So our first assignment is to load let me minimize this. So our first assignment is to load uh, to upload our file, and we have a folder to upload, which is our sales order folder. I've already downloaded the folder. So okay, before I go on, last week we were looking at upload a file. We uploaded a file last week because it was just one file, but today we have more than one file in that folder, so we are going to upload the whole folder since we are going to be needing it in our course of discussion. So we'll click on the folder icon, and then this is my folder, so I will now upload the folder. So it's letting me know that we have 3 files within this folder. Of course, I want the whole 3 files, so I will instruct it to upload. And then at this end, because I don't have anything yet, so I won't say overwrite, so I'm going to say it should upload. So we'll allow it to upload the folder, and it's ready. So we can close this window and we can see the folder. Initially we have only the table and the file section, but now we have the folder that we have just uploaded. So in order for us to see that folder, let us click on this folder, and we can see these are the 3 folders, and we can actually preview each of the file. So this is what we have. So the file is not actually empty. We can as well check if this one also contains data, which we can see, and we can check for the last one as well. Okay, great. So we are sure that we have our files intact that has been uploaded. So our next assignment is to create a notebook that we are going to use for coding. So if we look at this icon and we click the drop down menu, we can see existing notebook. If actually you wanted to use the one you have created before, but for this case we want a new notebook, so let's click a new notebook, and it's creating the new notebook. And here the notebook is ready. So at this top left hand corner, we can actually rename the notebook. What should we name it? Let's say Apache demo notebook. Okay, so this is our new notebook and this is our code. Like we said during the course of the presentation, you can use we have 2 type of cell. This is the execution cell, and this markdown is the content cell where you can use for your documentation, while we use this one for our execution of codes. So let us delete this cell. So let's go back to our lakehouse. So from our lakehouse here, we want Spark to load a code for us. That is our next. Sorry, I have not opened this down. So our next assignment is to create a code from this. So let us okay. So we are going to load using Spark. Let's minimize this so we can see. Um, okay, so what we can see on this code that it has generated for us is that it's reading the file from that 2019. It's reading the file from the format, and the format is CSV, and the option that it has, there's a header, that the header is true, and it's loading it with this ABS ABFSS Apache demo. That's our lakehouse. That's where it's reading it from. So, and the file is order from file section, and the folder is orders, and the file itself is 2019 CSV. So let us run the code, and it's going to display it in data frame format. So this type of code is what we call inferring schema. So let us run the code. The time for it to run depends on the size of the data, like I said. Okay, so here uh, we have the data frame, just as we saw in the presentation. And what we can see now is that this doesn't look like a header to me, like we have SO43, 704, 704, and this is 701. So it means that this is also like an order number. And of course, this is like a date, maybe order dates. And this is like a name, which is the name of the customer, the email, the product, quantity, price, and maybe VAT or tax. So with that, it means that we are going to change this code. The header is not true. So it means that it doesn't have a header. So let us again load the Spark. We load the Spark. Let's collapse this so we can see. So now we are going to change this header that is true. We are going to change it to false. So now that we have changed it to false, so let us load. Let's run the code now. Okay, so the code is ready. Now we have our first row. Now we have our first row, 701. Yeah, 701 is now our first row. But it has given us a header that is not really descriptive. So we can see underscore C0, underscore C01, and so on and so forth. If I scroll down to the end. So what we need now, these two instances we have used inferring schema. So what we are going to use now is our explicit schema, which we talked about earlier. So we are going to grab the code from our Microsoft Learn. So this is our explicit schema. So we are trying to define each header, because we can see, as we can see from this data, we can see that there's no definite header for this data file. So it is now our duty to define header for it. So here, what we are just doing is to define the header, tags, unit price, just as we explained during the course of the presentation the other time. So let's run the code. So now we can see we now have a beautiful header that is well descriptive. This is our sales order number. This is our sales order line number. This is our order date, our customer name, our email, item, quantity, unit price, and tax. I think this is beautiful and this is nice. So let's go on to our next task. So our next task is for us to we want to display we want to use wildcard to display the total all the files that we have. You remember that if we scroll up and we expand this our orders, we have 2019, 2020, 2021. But what we can see on our table is on this our data frame is just 2019. So we can use our wildcard to define to generate the whole of the years together. So let's get a new cell and let's code. But instead of having 2019, let us change it to a wildcard, and this wildcard we want to use. When you say select star from the table, it's going to bring out everything that you have in that particular table. So that's why we are using the star. So to bring out all the data. So let us run the code. So let us check. So now, yeah, we have 2021. So it is in descending order. So if we scroll down, it's going to take this. This is displaying like the top 1,000 rows. So we might not get to see 2020, 2019, but be sure that they are all there, because it's a wildcard that is bringing out all the data that we have in that folder, others folder. So let's see our next assignment. This time around, we want to explore to filter our data frame, like we saw in our presentation, that we can actually maybe call out 2 columns, or you want to see just 3 columns, depending on what. We are using our markdown cell to a kind of a little bit description of our documentation. So filter a data frame. So now let us click on that and let's grab our code. So what we are doing here now is that we want to call out only the customer name and their emails. And again, what we want to do, we want it to give us the total customer, the whole customer that we have, and then their distance count. We all know that when we talk about distinct count and count, when you have like one, two, two, three, 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 and then you want to count the whole item, you are going to count each item as one. But if you want to count distinct, you are going to count one as one. Even if 2 occurs like 3 times, you are going to count just 2 as 1. And then the number of times that 3 occurs, if it's just 1 time, you're still going to count it as 1. So instead of having like 6 items, you are going to have like 3 items under this thing count. So that is the difference between counts and distinct count. So we want to know our distinct count of our customer, as well as the total customer, the number of times each customer will come to our store, to come and place an order. So let us run the code, and then lastly, we want it to print it in a data frame format. So let us run the code. Okay, so now we have our customer count is 32,718, and the distinct count of our customer is 12,427 distinct customers that we have. So it means that we must have repetitive customers like we explained. And here, like we said, we want to see their email. So this is our customer name, and this is their email. So you can see that we didn't call out the whole of the data, that the whole columns that we have in that table. So let's move on. Next, we want to modify this code that we have just executed. We want to select distinct count of customer and their email just as we have it, but we want to use the where to filter the number of customers that we want to see this time around. We want to see only the customers that bought this particular product. We don't want to see all of the customers, but just the customers that bought this product. So that is why you are seeing where this item is equals to, this is the equal sign in this code, equals to this particular product. And so we also want the customer count and the distinct count. So let us run the code and let's see our new, compared to the number of customers we have earlier. So compared to the number of customers we have earlier, we now have only 133 customers, both count and distinct. And these names and emails that you are seeing are just the customers that bought that particular product that we have specified in that code. And we can go on to use our grouping like we mentioned in our presentation. We want to use grouping. So here we are looking at getting out this item quantity grouped by this item and the sum. So we want to see the item and the sum of the quantity by that item. So that is the group by. So let us run it. So now we have 130 rows. Yes, we can see the item and we can see the quantity, the sum of the quantity sold or bought by this item. So we scroll down, we can see it like that. So this is how we can use the select that we mentioned during our presentation, the where to filter, and the group by to show the groups, the groupings that you may like to see according to your desire, depending on what the organization wants to see. So here we want to again look at maybe a yearly sales. So here we are using the select function. I want to see the yearly sales by their order dates. Group by, we are still under group by order year. So we want to see the years and the order sales that was made for each year. So let's run the code and see that grouping and see how it come out. So now we can see we have 2019, 2020, and 2021, I think the company is not doing badly. There's increase for each year. Um, Hello, do we have? Am I still audible?
Yes, you are. But please, I have a question. I'm sorry to
Yes.
drag you back.
No, it's
I'm sorry.
fine. Sorry, you should have raised it. I can't because
Yes,
I'm
I did.
sharing. I
I
won't be
did,
able
but
to see your.
yeah, I
Okay,
did, but
sorry.
I didn't also. I did not want also to interrupt you when you were talking.
Okay,
So I followed you keenly from where you loaded the data and the executions you did, but
okay.
I didn't quite get how you loaded the page, how you got to load the page. I think you typed something like powerbi.com. I actually got
Okay,
distracted
okay,
then, so I
okay.
would
You
like
got
you
this.
can.
Okay, let me drop that on the chat. I think it's. Let me confirm that.
Yes. So I did this, but it requested for an email. That's to enter an email.
Okay. It asks you to enter an email.
Yes.
Okay, the truth is that you need to sign in with your own Microsoft. So I have an account with Microsoft. I signed in with my own Microsoft account. So that's why I'm able to sign in. And if you check my screen, you can see my logo, right? Can you see my image icon? Can you see
Yeah.
my screen?
Yeah. I can see. Yeah.
So you need to log in actually. You
Sorry.
need to log in. Yes, sir.
Okay.
Okay. So can we go on?
Yes, we can. Yes, we can.
Okay, thank you. All right. So from here, we also want to transform the year. So what we want to do, we are carrying out a kind of transformation. I think I should. Uh, where am I? Where am I? Where am I? Okay, so I'm here. So let me use a markdown cell. Let me see transformation. Okay, so that's fine. Okay, so what we are seeing on the screen is that we want to carry out a kind of transformation to the data. What we can see here, we can see 2019, and if we look at our table, if we scroll back up, yeah, we can see our order dates, and we can see our customer name. So now we want to carry out a kind of transformation that, let me scroll down here. Okay, so we want to do a transformation like splitting the years into a year column and a month column, or we want to call out a year column and a month column from the order date column, because the order date contains the year, the month, and the day. So what we want to do now is to do a kind of a simple transformation within the year, the order date column. Please give me from the order date column. Please give me a column called month, and from the order date, and a column called year from the order date. And here on the customer name, we want to do a transformation by splitting that customer name from the name being together, just as we saw, into first name and as well as last name. From which column? From this customer name column. And then we will now filter the transformed data frame. We want reorder it. You remember the time that we created an explicit schema. We gave a particular order that we want it to um, that we want the data frame to appear when the result is printed on the data frame. We requested for the sales order number, the sales order line number, and then we went ahead to to state them one after the other like that. So in this place as well, we want it in a particular order, so we want to reorder it from what we have set before. So the order we want it, we still want the sales order number, but and it says order line number. Next to it we want the order date. We still kept the order date column, but now we want the year column to follow it. Next to it is the month column. Next to it is the first name, last name, email, then the item, quantity, unit price, and tax. So that is the order we want it to be. And lastly, we want it to print just the top 5 rows. We don't want the whole of the items in the table. So now let us run the code. So running it, now we can see, of course, it has limited it to only 5 as we requested, and it has reordered it the way we wanted: the year, the month, the first name, last name, email, quantity, unit price, and tax, just like as we have defined it in that code. So now our next assignment is to save this our transform data that we have modified it, we have done all of that. So we have to do that. Okay, I just want to be sure if I'm not jumping any step. Okay, so let's run this code. Okay, so this has been saved. What we can do now, let us refresh our file section. Sorry, please, in case I'm not audible, let me know. Okay, so here we can see our transform data. We have saved it. Let's scroll up to expand this aspect so we can see. And and here we go, we can see it. And if we click on this, so we have our packets and we have our metadata. Okay, so our next assignment is to now write the packet and load it. So we have a new cell code in our code in there. We only define it to give it to partition it so of our transform data that we have saved. Okay, so this is it. We can see that our saved data is correct. The way we have transformed it is the way it has saved it. And we can see all the years. That time we only limited it to 5, just the first 5 rows. So now we have all our data complete. If we refresh our file, we are going to see, let's refresh our file. Okay. All right. Okay. So I think it's the next step that we're going to see our package folder. Let's get a new cell. Yeah, so by the time we partition it now to year, month, and then what we are doing under this code is just that we want to partition the year, month code so that we'll have it in section. That was what I was trying to look for the other time. I never knew that we have not actually run that code. So Spark job in progress, data saved. So if we refresh now, I guess we're going to see that. Yes, so this is the partition data. So we can see the partitioning year 2019. So when we open it, we can see this is October, November, December, July. And we can also see for 2020, we can see like that is partitioned, as well as for 2021, it's also partitioned. Okay, so what is our next assignment? Our next assignment, our time is running fast. Our next assignment here is that we want to read this file and load it. And after loading it, what we want to do what we want to do now is that we want to create a table from this table data frame, that's the other data folder that we have just done. So we want to work with table using SQL now. So we want to create a table. Last week we were looking at delta tables, and we said that when you have the triangular icon, it shows the delta table. So once you see the triangular icon, you know that, okay, this is actually a data table. I'm going to see shortly. Creating, sorry, let me edit that. Create a table using. Okay, I just wanted the headings like that. So let's grab the code and so here, this is how we write. We actually dealt with this last week. That is why we are not spending much time on this one. We write the format. The format is delta, and save as is what we use to save the table, and we are saving it as sales orders. And then where are we getting the table from? We want it to describe the table extensively, and we actually dealt with description of table last week as well. So let us run the code, and then we'll take it up again from there. So we give it a minute for execution. Okay, so It's still working fine. It's done. So now we can see the description we are talking about. Here you can see the column name is data, column name, the comment, the data type. We see sales order is string, sales order. So these are column names. This is data type, and then sales order line number integer, order date, column, customer name is string, the email is string, the item is string, quantity is integer, unit price is float, tax is float, and then if we go down, detailed table information that we want to know about this Spark table, and it's telling us that the type of table is managed table. Last week we explained what a managed table is and an external table is. So a managed table is a table that is managed within this Spark Databricks, while external table is managed outside the Databricks, but the files are stored in the file section folder. So, but it is not managed within the Fabric. I mean, it's within Fabric, but not within the Databricks in this lakehouse. So we have the owner, trusted, and then the table properties. You can see that the table is Delta. So let us, because we have created a table, let us refresh the table section. Ever since we'll be dealing with the file section, now we are now dealing with the table section. We'll give it some minutes to refresh. Here we are. So we can see our sales order table. We can see the triangular icon we talked about that represents a delta. So whenever you see this triangular icon, you know that, okay, this is a delta table. Okay, so let's move on. And our time is running fast. So next we are going to use select. So select from that so we can see the content of our table in that frame. We all know that select star, like I said earlier, it means that it's going to bring out the whole content of what you have in a particular table that you are selecting from. You are selecting from our lakehouse, and which table are we selecting from? This sales order table, and we are limiting it to 1000. We don't want it to bring out everything. How should it display it? Should display it in a data frame format. So let us run the code. Uh-oh. I guess, okay. Don't worry, let us load it directly from here. Let's load the Spark from here, and let's run it. Because what they have here does not correspond with what we have in our lakehouse. So our lakehouse description is different. That was why we had that error. Okay, so now this is what we have. We have our customer name, we have our email, we have our item. So we see that the data we have earlier in the orders folder here is the same as what we have in our table, in our Delta table, in the table section. Okay, so let's go ahead to use SQL magic code.
Sorry, can you please repeat how you got that?
Which one?
That part, how you loaded it.
Oh, okay. So let's load it again. Fine. That's great. Let me delete this cell. So actually, we copied this, right? And it gave us error. The reason it gave us error is because you see your lakehouse. So your lakehouse means that I should give the description of my lakehouse. Remember, the name of our lakehouse is Apache Demo Lakehouse. So your lakehouse is not the same as this. So that is why it didn't recognize that. So that is why I loaded it directly from here. When you click on these three dots, we call it ellipses, and you click on it, you see load data. And when you follow the icon, it will say Spark. This Spark will generate what what we call inferring schema. So when you click on it, it will generate the schema for you. So it has generated the schema. It knows that this is what you want to do. So instead of load from your lakehouse, it's not giving us from Apache Demo Lakehouse, which is our lakehouse name, dot sales order. Is it clear, sir?
Yes, ma'am. Thank you.
Okay, very good. So if we run it, we'll still get the same result. So let's just run it. Let's scroll down. So this is the result. So that's how we load. And if you want to load from the file section, so let me just go back there. If you want to load from the file section as well, if you click on this, so let me go up here. So let me expand this icon. It will bring you down to this place. It will open up this is the file section, and these are the files under the order. So if you want to load 2019, for instance, you also click on the ellipsis, and it will ask you, do you want to load Spark or you want to load Pandas? But because we are working with Spark, so if you click on Spark, it will also generate the code for you. Let me close this session so that you see that again. That was the very first one we did, actually. So did you see it, sir? Can you see this, sir?
Yes.
Hello?
Thanks. Yes, I can. I can.
Okay, so it's clear. Okay.
Yeah, thanks.
So that's how we can load the Spark inferring schema either from the table section or from the file section. So let's just delete it so we don't get confused. Okay, so let's move on to our next code. Our next code is that we want to use our magic, we call it magic, we call it magic code. And we are referring to this double percentage, um, this double percentage sign. So when you have the double percentage sign and SQL, it shows that Spark knows that you want to run a SQL query uh, below it. If you have the percentage, the double percentage, and you have like py Spark, it knows that, okay, this code you want to run is Python, and on like that. So we are selecting the year order date, and we are saying that it should sum after multiplying the unit price by the quantity and adding it to task. So it should now sum it and give us the sum. And then from the sales order, it should group the order date and call it order year. All right, so this is grouping. We are using a SQL select query to group this time, and let's see the results. Okay, so we can see the year now. We now have 2019, 2020, 2021, and this is the summation. So you should call it gross revenue, and this is what we have. All right, so now we want to visualize data. Excuse me. So let's use our markdown again. Let's say I hope the spelling is correct. All right, so now we are moving on. Again, we want to use select star from. We already know what select star is, and we already know our magic code. We are selecting star from where? From the sales order. So let us run the code. Alright, so this is our code. This is our data. We are already familiar with this. So let's move on. And what we want to do now is that we want to visualize this in a table format and in chart format. So if we look at this, this is table format and this is chart format. We have not been using it since because we have not gotten to this section. So if we click on this chart now, we can see that give me a minute. I don't know what should I do now. Let me minimize this and let me expand this. Give me a minute. I don't know why it's running away. Okay. All right, so we can see that this is the chart format, but this chart isn't very conspicuous. It's not actually readable. So we can customize it using this icon. So if we click on it, of course we still want a bar chart. So but this sales order number, let's use the item instead. That's the name of the product, and then the value line number, let's use quantity instead. So let's remove it from line number to quantity, and then average aggregation, let us use a sum. Let's use the sum and let us apply, and let's click on this icon back. Okay, great. So I think we are now seeing the charts very well. It's more descriptive now. For this one we have 5, and for this we have 20. For this the total sum of quantity is 133, and on like that. So this is a good chart. So again, let's go back and bring up our, okay, I think we can reduce this. I wonder. Okay, so let me reduce this. Okay, so let's go on. So from the above, we want a more descriptive, we want a kind of, okay, so here we are trying to get the year order date as character and as order year, and we also want the sum of the unit price, just as we described earlier, as gross revenue. And then we also they are all coming from the table sales order table. I want to group by the order date, and we want that order date to be named as order year by the time it appear, and we want it in data frame Spark. So let us run the code and see. I wonder. Okay, so now we have seen this is a form of a table. We have order year and we have the gross revenue. We have all the year. You remember we group by year, and this is a gross revenue. It is same what we have here that we have reduced to this format. So our next assignment now is that we want to use our import library from pandas to design this particular to represent this table in a visual that is more appealing. Sorry, let me quickly use our document to see. Okay, so here, what are we trying to write here? We are importing matplotlib as py plot. Py means Python plot. We are plotting it as plt. The plt is the short form of plot. So, and here we require the matplotlib to do a particular job for us, to read it pandas, and then here we want it as a bar chart. And how do we want it? Sales as order year, and then we define the height, the gross revenue, and then the the x-axis is sales, while the y-axis is our gross revenue, sales order year, sorry. And then we want it to plot the show means that it should display the visual for us. So let us run the code. So here we go. We have what we have here is what we now use a matplotlib to plot as a bar chart. So we have the 2019, 2020, 2021, and this is our revenue, and this is our order year as we have described. But the shortfall of this is that we don't have our x-axis and y-axis label, and we don't have title. So that will be our next assignment, to give it a title and to give it also to give it a label. So now we have we must define the matplotlib at the beginning, and then we'll go ahead to, we've explained this the other time, we are now customizing our chart. So we want a title, so the title should be revenue by year. We want the x label to be year and the y label to be revenue. We also added that it should give us a grid and it should have a color, and the grid line should be a dotted line and not a block line. And then we went ahead to give the line width for the x-axis and the y-axis. So again, this is to display the visual plt.show, that's plot the dot show. So let us run the code. So now I think there was something I missed out. The x-axis the rotation should be in angle 45, and that is why you can see the 2019 in this angle. So you can actually display the way you want. We have the revenue, we have the year, and we have the revenue by year as our title. If we go up here, you can see that the 2019 labels are actually in horizontal form, but because we have modified it, customized it to our taste, to be in angle 45, and that is what we can see. With this, we can actually modify this further, maybe If you need a space, we can actually customize this further to reduce the total size of the entire visual. So let us go ahead and use this code to do that. So to do that, every other thing remains the same except for the fact that we are reducing the figure here, the figure size of the entire visual. We've reduced it to 8,3. And so if we run it now, we are going to see that difference in sizes. So we can see the size of this visual compared to what we have earlier. So actually, you can customize your visual the way you want it to be. So still based on the same criteria, but this time around we have our visual, and here we are now having two visuals instead of one. We have our bar chart and then our pie chart. We included a pie chart to what we want to see this time around, and then we want our pie chart to be yearly count. So, and we set the title to be orders per year. That's going to be the title of our pie chart, and the title of our bar chart is revenue by year. And of course, the entire report name is called sales data. So let us plot this visual. Let us run the code. It is the code that will plot it for us. All right, so we can see we have the report name is sales data, and this is our revenue by year visual, and this is our orders per year visual with the legend stated 2019, 2020, and 2021. So we know that this is 2021, this is 2020, while this is 2019. So now we moving on. I think we are now moving on to Seaborn. Want to move on to Seaborn library. So let's write Seaborn. Okay, so just as we define matplotlib, we also define Seaborn whenever we want to use it. If you don't define it, it will not be recognized and you might not be able to use it. Okay, so the import Seaborn as SNS. The short abbreviation acronym for Seaborn is SNS, but you must write it in full as import Seaborn as SNS before it's going to perform the job for you. So again, we want to plot the same data using bar charts, gross revenue, and then data sales. So it's the same as plt.show. So let us run the code just as we've explained in the matplotlib. All right, so this is our bar chart. We have our gross revenue, order year, and we have the year defined. Next, if we want to modify this or customize this as the case may be, we can do that just as we in matplotlib. So here we are setting the theme. This is already clear. And here we are setting the theme style to be white grid. So it's going to put a grid line on it. This time we didn't define that it should be a dotted line, so automatically it's going to be a block line. And then here we are still saying it should give us the bar chart and every other parameter that we have defined earlier. So let's run the code and let's see the visual output. So we can see that this is not as sharp as we have it here because we define a theme for it. And like I said, we have our grid lines. It's not dotted because we didn't state that it should be dotted line. So now we want to plot a line chart using Seaborn. It will not be that. Is it only bar chart that this your import library can plot? So we are using line chart this time around, and we have the line chart. We are defining the X and Y axis, order year, and gross revenue, and plot the show. So let us run it. And here we go. This is our line chart. So with that, we have actually come to the end of today's exercise. And the last assignment we have is for us to clean up our resources. So assuming you are just practicing on your own, it's just a demo. In order for your money not to be running, for it not to be accrued to you, it is usually advisable for you to remove the workspace, uh, and then if you want to try something else, your money can be saved. But if it's for an organization that you have already have license, and you don't need to erase the workspace. So to clean up the workspace, you go to workspaces, you locate the workspace. This is Apache demo workspace. You click on the ellipsis and you click on workspace settings, and then when you get to workspace settings, you click on others and you see remove workspace. So once I click on this remove workspace, everything that we have done will be erased. Do we have any question?
So, why we thank you so much for the teaching. That's so a lot of information have been shared. Thank you so much. So, can you please avail us the recorded version of the class, please?
Yes, the recorded version of the class will be made available unto us. I can see a question here. Hello, Anna. Please like to ask how we're able to get some of these chart sizes, e.g. 07 page. I didn't understand though. More so, can we see the use of Seaborn Matplotlib libraries of Python being engaged in here? Yes, we have done that. We have actually completed that. I think, Victor, you can reach out to me. I didn't really understand this 0.7. I didn't get that.
Okay, hello, Hannah. Good evening. Good afternoon.
Yeah.
I'm audible. No, actually,
Yes.
because I noticed oftentimes at the point of things like this, I don't know, maybe either it's been taught before. How you're able to, by the time you're about to settle on your chart, that you said, okay, maybe sizes, for example, this one is 0.7, another one is this, I don't know, is it automatically computed, or how do one really know what to put into, for example,
Okay,
when
the
you were doing
sizes.
your
Yes, yes,
the,
the
the bar
sizes.
chart and all that? So the
Yes,
second
the
one, I
size.
was just saying, because I'm seeing engagement of Python and all of that, even in Spark and all that,
Yes.
the reading, or could there be even a deeper material you can advise? Maybe somebody can really be able to read this data frame properly, please. So that's what I
Okay,
mean.
so
Thank you.
okay, so for the data frame, right? During my presentation in the slide, I mentioned that Apache Spark actually supports uh, multi languages as one of the features, and we said it supports Python. We said it supports Scala. We said it supports Java, and we said it supports SQL, and we said it supports R. So there are a lot of languages that it supports, and which uh, uh, you can read up. For the purpose of our demo today, you can actually find resources in the Microsoft Learn, and some other places that you can see scripts. You can do like aka dot is it a Spark script notes? Yes, you'll be able to get script notes there as well. Also, can we see the use of Seaborn, Matplotlib libraries of Pythons being engaged? Yeah, I think we have done that. We have seen Matplotlib, we have seen Seaborn. We were able to plot bar charts, par charts, and line charts with these two libraries.
Okay, so it appears we don't have any question again for today. And you are saying something.
Yes, I say over to you. I'm handing over back to you.
Okay. Even me to have been learning since though. It has not been easy, but we thank God. Let us clap our hands with emoji on the platform for Anne. It's not easy. For the past 2 hours, there has been dismantling Apache Spark, and it's wow. Honestly, it's wow. So for as many of us that came today, I'm sure we get value for our time. But I'm a bit concerned because we're just 10 on this call, and this is not our culture. I mean, the minimum people we have on this call has been 30, 25, but today is 10. I don't know the reason. Maybe it's because somebody has not told somebody who has not told somebody who has not told somebody. So when we are coming next week, I think we'll be rounding up data engineering next week.
We've
So,
rounded up today. Oh.
okay, today. So we'll be
Next week we
moving
are going
to
data science.
we'll be moving to data science next week. So please tell someone, don't come to class alone. Tell someone we're not playing here, we're doing real business. This is an opportunity. Who knows? We all know that Dynamics 365 is you must have license to use it. Who knows after this free version class, probably um, Fabric might not be free. Who knows? So now that we have access to use it for free, let's take advantage of it. Our speaker cannot teach us everything in class. We still need to watch this video over and over again and try to replicate all that she has done. Have you not experienced this thing whereby you have to watch a video over and over, maybe 4, 5, 6 times before you can get what you need to know from that thing. So learning is a continuum, it doesn't end. So let's try and continue to learn and continue to learn. That's the way to demystify Microsoft Fabric. Thank you so much. So at this point, I want every one of us to on our video so that we can do a snapshot of today's class. I want to see your beautiful faces, Ele, Nebechi, Sister Anne, Master Wale, Onioluwa, Oluwa Sanjo, Victor Bassi. Let's see your face. Yeah, face so that we can shut down the class for today. I'm only seeing myself and I'm not seeing any other person. No. Where are we? Are we hiding our faces? Can anyone hear me?